So today we're going to move to section 9.4, which is all about vectors. And the assignment that's posted for you, I'm actually going to do the first page and a little bit more for you in these notes. Vectors are a quantity that has both a magnitude and a direction. Vectors have a lot of applications. If you're in physics, you may have talked about vectors. If you take college physics, you definitely will talk about vectors. There's a quantity that has a magnitude and a direction. So this is where we're not just talking about speed, but we're talking about something like a velocity where it's going in a specific direction, or we're talking about forces pushing in a direction. There's a lot of applications in physics where vectors are used. When we draw a vector, it's represented by an arrow. So we're going to draw vectors on the coordinate plane today. And then we're going to look at how you can add vectors kind of in a very visual way. So here we want to sketch a vector with a magnitude of 4 and a direction angle of 90 degrees. Magnitude is the length of the vector. The direction angle is the direction it's going in. So here for A, I'm going to start the vector at the origin and go at an angle of 90 degrees with a magnitude of 4. So I'm going to go up 1, 2, 3, 4. I'm going to draw an arrow showing that the direction of the vector is at that 90-degree direction. When you label vectors, you use a lowercase letter. And what you'll notice is if you look in the book, the letters are all in bold. But since you can't write with it by hand in bold, you draw a one-sided arrow on the top of it. That's the vector symbol. B, a magnitude of 3 and a direction of 0 degrees. Here's 0, magnitude of 3. Here's my vector. I call it B. Again, that's a one-sided arrow on there. C has a magnitude of 5 and a direction of 180. So 180 is the negative x-axis. 1, 2, 3, 4. 3, 4, 5. Here's my vector C. I draw the one-sided arrow above it. The last two, I see a magnitude of 4 square root of 2 and a direction of negative 45 degrees. These are all things we can draw exactly on these axes. 4 square root of 2 is our hypotenuse of a 45, 45, 90 that has legs of length 4. So if my direction is negative 45 degrees, I'm going down into fourth quadrant here, negative 45, and my magnitude is 4 square root of 2, I have to end up 1, 2, 3, 4 over and 1, 2, 3, 4 down. The end of the vector would be, the vector is the hypotenuse of that 45, 45, 90 triangle where the legs are both 4. This is D. And then vector E has a magnitude of 5 square root of 2 and a direction of 225. Again, 225 is a multiple of 45. So the hypotenuse being 5 square root of 2 means each of the legs is 5. So we're going to put the end of the vector there, connect it, and this is vector E. We can also think of vectors with directions. So here, this vector is directed east with a magnitude of 5 feet. So if I have north, south, east, and west on here, east with a magnitude of 5 means I'm going to go 1, 2, 3, 4, 5 in that direction. That's vector A. B is directed south of the magnitude of 4, so I'm going 1, 2, 3, 4 down. That's vector B. And C is directed northwest, which if we just say northwest, we're going to assume is directly between north and west with a magnitude of 3 square root of 2. So over 3 and up 3, there's my 45, 45, 90 with a hypotenuse of 3 square root of 2. That's C. Two vectors can be added by completing a triangle. So we're going to add using what's called the head to tail method. The first vector is drawn with its initial point at the origin, and the second vector is drawn with its initial point, its head, at the terminal point or tail of the first vector. You add one to the end of the other. The sum is called the resultant vector. You have to draw in the resultant vector. It is drawn from the origin to the tail of the second vector. The resultant vector adds together the other two. So here we have vector u that is directed east with a magnitude of 10 feet. I think the scale just goes out to 10. And we're going to add to that vector v, this is u, which is directed north with a magnitude of 15 feet. So from the end of u, I'm going to draw the first vector coming from the origin, and from the end of that, I'm going to now start my second vector here. And I'm going to go 1, 2, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is actually right above this. I'm going to go 15 in that direction, and that's v. What I want to do is determine the magnitude and direction of u plus v. And you can see again here how they're bolded in the directions. When I add them, I start at the origin and I draw one vector that goes from the initial point at the origin out to where the second vector ended when I added them head to tail. This is the resultant vector u plus v. I need to find the magnitude of that vector. Well, we went across 10 and up 15, so I can use Pythagorean theorem to find the length of that hypotenuse of that right triangle there. And this ends up being square root of 325. So then that's 5 square root of 13 is my magnitude. And I need to find the angle. So the east is 0. I need to figure out this angle. I know that the tangent of that angle is 15 over 10. So theta is the inverse tangent of 15 over 10. That angle. Now, this is the only problem in this entire assignment where you would have to use a calculator. And we're going to do this in degrees for these vectors. So if you put in your calculator inverse tangent of 15 over 10, you get an angle of 56.31 degrees. So this is a vector with a magnitude of 5 square root of 13 at the angle 56.31. Now, for the rest of this activity, you do not need a calculator at all. There are a lot of applications that can be modeled using vectors. All of these problems involve special right triangles, so you don't need to use trig, you don't need to use your calculator. This one says, what is the resultant, we're adding, of two forces if the first force is directed downward with a magnitude of 10 pounds and the second is directed to the left with a magnitude of 10 pounds. So imagine two different forces pushing on the same object. We're going to draw a coordinate plane, and we're going to add these two vectors to head to tail. The first force is directed downward with a magnitude of 10 pounds. So start at the origin for the first one and go down what we're going to call length of 10. The units are pounds, but we're just going to consider that as if it's a length. It's the amount of the force. The second is directed to the left with a magnitude of 10 pounds. So we need to add these head to tail. You go to the end of the first vector and then add, I'm going to go to the left with a magnitude of 10. What I want to do is find the resultant. The resultant starts at the origin and goes to the final point. You go from your first point of your first vector to the last point of your last vector. We need to find the length of that vector, the magnitude of it. Well, this is a 45, 45, 90. The legs are both 10, so the hypotenuse is 10 square root of 2. And we need to find the direction that it's going to head in. The direction, we're going to go from 0 degrees around like we normally do with positive angles going counterclockwise. And that angle would be 45 degrees past 180, so that would be 225. So the way we're going to answer these is that it is a 10 square root of 2 pounds force at 225 degrees. For the rest of the problems in this activity, you should be able to draw a picture that it has a 30, 60, 90 or a 45, 45, 90 if there is a triangle, and you're going to find the magnitude and direction from that. One comment as you go through this, actually I'm going to do number 6 for you. In number 6, you have vector u that has a magnitude of 500 feet directed south, and v that has a magnitude of 500 feet and is directed north. If I draw u from the origin, I'm going to go down 500 feet. Then I'm going to add to that from the tail. I'm going to start the head of a vector that is 500 feet and is directed north. When I add that on top, I end up back at the origin. Those two have canceled each other out completely. When they cancel out, we just call that the zero vector. It doesn't have an angle associated with it because it has no length. So if you get something that cancels out, it is called the zero vector. You should be able to work through the rest of these. There's a couple at the end where you need to make sure you find your 30, 60, 90, and 45, 45, 90 triangles. You have until next Tuesday to get this done because there are no classes on Monday or Tuesday. So work on it whenever, and I'm going to make the due date end of the day Tuesday.